We've explored a lot of function properties, right? Let's put them all together and put them to use. So here's a function, okay, kind of a fun one, a little interesting. And I have a series of questions here. I want you to pause the video, try to answer them for yourself, okay? And then resume the video when you're ready to see the answers and hear an explanation. Here are my answers. Okay, so over what x intervals, if any, is the rate of change of the function negative? This whole bit of language, that's just another way of, a fancy way of saying decreasing. So rate of change, again, is instantaneous rate of change, whereas the slope of the tangent line, right, is negative. So that's the instantaneous rate of change. And so that ends up being negative infinity to -3, so this piece of the graph here, right? And then, again, that's increasing, so that's actually where I got my interval 3, -3, 0 in part B. And then, let's see, that is increasing still, so 3 to 0. Okay, so that's why I stated it there. Here it's constant, 0, 1, an x interval, not a point. And then let's see, this is increasing. So from 1 to 2, it's increasing. And then from 2 to 4, the function is decreasing as I go from right to left. It is falling vertically. So that's 2 to 4 would be where it's decreasing. And then from 4 to 6, it would be increasing. Okay, so I covered the first three with all that. Okay, now it says identify all relative extrema. And so it says, okay, if I look pictorially, right, I see a valley here, a hill here, and a valley there, right? So I can talk about local mins, right, at each of these x values. So -3, there's a min of -2, right? And then at x equals 4, there's a min of 0. And then at x is equal to 2, there's a maximum of 4. Okay, so that's what I have. And then are there any absolute? There is a minimum, right? So the smallest y value I obtain is -2 when x is -3. And a maximum, don't have any, okay? Because again, this function would continue going upwards. And then concavity. Okay, concavity was a little tricky. Concavity, so where's a concave up? Where's it a bowl shape? From -infinity to +1, or sorry, -1, my bad. Okay. From -1 to 0, yes, it is increasing, but it isn't bendy. It's a straight line. So there's actually no concavity associated with that, nor from 0 to 1. That's a little tricky. Then as I look at the region when x is -1 to 4, it is concave down. That I could imagine a little head there that I could put on, or a hat that I could put on my head. Okay, and then from 4 to 6, right, it's bending upwards. I could imagine filling this with water and having liquid stay in there, okay? Or at least that being the right side of a bowl. So that's where I have concavity, from 4 to 6. Concave up being from 4 to 6, okay? And so with this notion of point of inflection, I'm interested, like, where is it changing concavity from down to up to down? And so the only point of inflection we have is at 4 comma f of 4, because before that, right, yes, it switches from concave up to concave down, but there's these regions that aren't bendy. So I can't talk about those being points of inflection because I have to specifically change from concave down to concave up. Okay. So little tricky with concavity there, but just make sure you're paying attention to the definitions and the overall concepts. Next example, and these are super fun and aggravating at the same time. So we have to kind of imagine now, we have to draw a sketch, and whether your sketch looks like my sketch, it doesn't matter. I'm looking for the properties. So I want to sketch the graph of a function that has a positive rate of change for when x is less than 0 and when x is greater than 4, negative rate of change. So, okay, let's just maybe pause there. Positive rate of change. Okay, so this means that it's increasing, right? And then here, negative rate of change, that's decreasing. Okay, so it's decreasing there, concave down, and has a point of inflection. Okay, so it has to change concavity. So we know it's concave down before that, has a point of inflection there, so it has to change to concave up after. And then we have to classify all extrema. Oh, there's not anything to do. This is going to be simple. Yeah, right, it's a lot. Okay, so first let's get a little sketch going. Okay, here are my axes, and I'm wondering, okay, the y values are not going to matter as much. Okay, we'll have to have some, but I'm more concerned about the x values. What are the major x values I have to pay attention to? 0, 4, and 2. Okay, so there's 0, 1, 2, 3, 4. Okay, I didn't say anything about the domain, so I could have a domain of all real numbers. I don't know. But let's just kind of think this through a little bit. Okay, so I'm just going to kind of sketch, and then if I need to erase and redo, we will. So it says the function has a positive, so it's increasing, right? So it's increasing for x less than 0. So I would have to say from going from left to right before 0, it's going up, okay? And it also has to go up after 4. So, okay, it looks something like this. Okay, I haven't taken concavity into consideration. Let's see, it says negative rate change. Oh, so it's decreasing between there, so it looks something like that. Oh, okay, this is looking good. Concave down. Okay, so now this is bendiness, concave down, right? That looks like this. So I just maybe have to say for x less than 2, it has to look like a hat. Okay, so maybe I know it has to go up like this. I'm just going to make it the hat maybe a little bit more pronounced. Okay, and then it says it has a point of inflection, so it has to change concavity. But again, in here it's still decreasing, and then it has to be concave up thereafter. Okay, oh, that doesn't look too bad. Okay, so that's my sketch of the function. Okay, again, I'm increasing up until 0, decreasing between 0 and 4, increasing thereafter. I have concave down, but less than when x is less than 2. Point of inflection, meaning it changes to concave up at x is equal to 2. Okay, last thing, identify all extrema. Okay, because how I have my function, I have no absolute extrema. Okay, now maybe in your sketch, the way you made it, maybe there is an absolute extrema. Maybe you made things a little bit more pronounced. Sure, that's fine. At least based on my sketch, there's no absolute extrema. Okay, and then what I can say though is that there are local maxes and mins occurring, right? So I have a local max, and I'm just going to say at x is equal to 0. Okay, what I could do is say a local max of f of 0 at x is equal to 0. That would be okay if you want to include the full language. And then I'd have a local min of f of 4 at x is equal to 4. Okay, I don't know what the y values are, right? Because I made a sketch, so my sketch could look different than somebody else's sketch. But this way we kind of capture all those different cases. Okay, so here we have it. We've worked through an example where we have to produce the graph given some conditions and properties of the function. And we've actually worked on identifying the function or the function properties based on a graph that's given to us. So we should have increasing, decreasing, concave up, concave down, points of inflection, extrema, all in our toolkit now to talk about with any function.